All right, so we're going to start with a very simple example, and this is going to be easy, but it's going to actually help us apply the laws of balances to a specific situation and make us think in those terms. So let's ask the following question. How much gas do I need to buy and put in my gas tank every week? So first of all, it's always helpful, really in any problem, to draw a picture and then clearly define the system. Okay, so pretty rudimentary drawing here, but let's just say this is the gas tank in my car, and it's just some, box basically. Well, first let's define the system. What we really care about is how much gas we need to be putting into this box every week. And so let's just define the system as the contents of the gas tank. In other words, it's a control volume. It's anything that's inside this control volume, which is this dashed line, which is the contents of the gas tank. Anything in this control volume, that's the system. Okay, so we have the system defined. And then next, let's apply the generalized balance. So you can really apply this to anything. And we'll start with the most generalized form, which says that the accumulation of something within the system is equal to the amount that we put in minus the amount that we take out, plus the amount that's generated minus the amount that's consumed. And specifically, we're going to be talking about the mass of gasoline going into and out of this gas tank. It's not going to be consumed within the gas tank. It's going to go to the engine to be consumed, you can say, but it's not going to be consumed within the gas tank unless something very bad is happening. And it's not going to be just generated spontaneously within the gas tank. We might put some in with our pump into the gas tank, but it's not just going to be generated within the gas tank. So right off the bat, again, we're talking about mass, and because of that, and there's no chemical reaction going on in the gas tank itself, because of that, we can already simplify this. There's none generated, there's none consumed within our system, which is defined as the contents, the control volume of the gas tank. So here, accumulation equals input minus output, which means that, just like we talked about in the last video, the change in mass from the initial to final state will simply be equal to the sum over all the mass that goes in minus the amount that goes out. So if we want the gas to remain at the same level from week to week, what do we want the accumulation to be? Again, if we want the amount of gas in our gas tank to always be, let's just say, full, then what do we want the accumulation to be from week to week? Well, we don't want the amount of gas to go down. We don't want the amount of gas to go up. We want no accumulation. We want the amount of mass of the gasoline in our gas tank to remain the same. So the accumulation is actually zero. That may seem a little bit non-intuitive, but think about it and repeat the video of what I just said if that's unclear. And then let's think about this in terms of some specific numbers. So let's say M1 is the amount of gas that I put in. So M1 is the input. And I'm only going to go to the gas station once a week. So there's only going to be one time that gas goes into the car, into the gas tank, and that's going to be the amount that I put in, M1. And then let's just say, to make it clear, let's say I use a kilogram of gas myself a week to get around town. Let's say I share the car. Let's say my friend uses the car once a week to do whatever they need to do. Let's say they use maybe about a third of a kilogram of gas. So let's say that they use 0.3 kilograms. Let's say that my car is kind of old and the tank leaks a little bit, or screwing on the gas cap leaks a little bit, and so some evaporates or leaks out the bottom. And let's say that leaks another, let's just say 0.05 kilograms. And I'll just leave the kg off there, but we're talking about kilograms. Well, then actually we have enough to solve for our unknown variable, which is M1, which is the amount of gas that I should input into my gas tank once a week. So we just move everything to the other side, and we get that M1 is equal to 1.35 kilograms. So I need to buy 1.35 kilograms of gas, and we could convert that into gallons or whatever we want, or cash, depending on the price of the gas or whatever. Regardless, we know how much gas I need to buy every week now. So work through this example again. It may seem really simple, but this idea of going from this general equation to putting it in mathematical form, to putting in specific numbers, and actually getting an answer, it's actually a useful thought process. So this is really the simplest kind of balance to do, are these mass balances where there's not even a chemical reaction and there's only one species, there's only one compound, but things are only going to get more complicated from here. Now, I do want to point out something interesting. We said that the accumulation was zero. We said that the accumulation was zero because regardless, at the end of the week, I don't want to have lost any gas out of my gas tank, and I don't want to have any more in my gas tank. I want to just maintain a steady level. That way, I always have gas for the next week. However, you actually don't know how much gas I have in the gas tank. There's actually nothing about this problem that requires you to know that, and there's no way you could figure that out from what I told you. In other words, at the end of the week, my gas tank may be full, and then we use up this amount, and then we replace it, and it's still full at the end of the week. Or maybe it's halfway full, and then we still use up this amount, and then we replace that same amount at the end of the week. Maybe it's a quarter full. Maybe I go all the way to empty, and then by the end of the week, and then I replace it with 1.35 kilograms of new gas. So there's actually nothing about this problem that lets you derive what amount of gas is in the gas tank. All you can know is how much you have to buy to maintain that steady state condition where there's no accumulation. And by no accumulation, I mean that there's no gas increasing in the car and there's no gas decreasing in the car. It's a steady state value. It's the same at the beginning of the week as it is the end of the week. And that's going to be a very important concept, that concept of steady state operation, which simplifies our equation here, and we'll see simplifies a lot of situations when we think about them. And indeed, a lot of things do tend up to end in steady state, where there's not actually anything changing. There's no net accumulation of a certain quantity that we're analyzing. And we'll see more examples of that to come.